Good morning, students. Today we'll see the topic is linear regression in machine learning. The content of this discussion: regression examples, then linear regression. Regression is the type of supervised learning. Supervised learning have two types. One is the classification, another one is the regression. Here the regression is to study the relationship between two or more variables. Here we can use simple regression if both the dependent variable and the independent variable are numericals. The dependent variables is represented by dv, the independent variables is denoted by iv. If the dv is numerical but the iv is categorical, it is used to use the analysis of variance method. Here we will see the examples. The following situations where we can use the regressions. The first example, testing if IQ affect income. Here IQ is the IV, that is the independent variable, and income is the dependent variable. The second example is testing if hours of work affect hours of sleep. Here dependent variable is hours of sleep and the hours of work is the IV. The last one, testing if the number of cigarettes smoked affect blood pressure. Here the number of cigarettes smoked is the independent variable, but blood pressure is the dependent variable. This is the examples of all the regression. Here displaying the data when both the dependent variable and independent variable numerical, we can represent the data in the form of scatter plot. Here x-axis in the IQ values, the y-axis in the incomes. Here we'll see the data points in the dot lines. It is necessary to perform a scatter plot because it helps us to see if the relationship is linear. So the main use of scatter plot is to describe the relationship between the two variables. Here's another examples. Y-axis is the chance of heart failure. X-axis is the body of fat in the percentage. In this example, the relationship between body fat percentage and the chance of heart failure is not linear, and hence it is not sensible to use linear regressions. Next, we'll see the linear regressions. Have linear regression and simple linear regression and multiple linear regressions. First, we discuss the linear regressions, the simple regression model that gives a straight line relationship between two variables is called a linear regression model. Here only represent the straight line relationship between IV and the DV. The same examples, the x-axis is the income, y-axis is the food expenditure. It is the linear. The income based food expenses increases. The second one is the same parameters, the same variables, but the graph is not linear. It is the non-linear. So the figure shows the relationship between food expenditure and income is linear. The second one is describe the non-linear relationship between the DV and the IV. Next we see the linear model. In regression, the relationship between y and x is modeled in the following form. Y equal to a plus b into x plus e. In sometimes y equal to b naught plus b1 into x plus e. Here e is the error term of each observations. It is denoted by small e or caps E. Then y is the dependent variable. From the examples, y is the income. X is the independent variable. It is the IQ in the example value. A is the intercept. B is the coefficient. So B is taken from the slope value. X is the independent variable here. B naught is the y-intercept. Y is the dependent variable. This is the main form and equation is following in the linear model. Here, floating a linear equations. Here, y-intercept and slope of a line. Here, x is the 5, 10, 15 is the values of variable. Then y-is is the scale is 50, 100, 150. Here, draw the slope. X is 0 at the time y is 50. Next, x equal 10. The y value is 100. The slope is y equal, the linear model or linear equation is y equal to 50 plus 5x. It is the plotting a linear equation diagram. The next one is the y-intercept and slope of a line. Here the same x and y values. Here y-intercept and x changes in x. Next one y changes in y factors, y variable. The first one is the linear equation diagram. The second graph is y-intercept and slope of a line. Next, assumption of regression. Here, there are no clear outliers. This can be checked by the performing the scatter plot. The outlier can simply be removed from the analysis. The outliers is indicated in the red in the figures. So, the y value or variable is the income. Xs is the IQ. Here's the samples in the linear, but outlier is the can be simply removed from the analysis. The scatter plot is used to verify the performance. Next, one more examples for linear regression. Linear regression is perhaps one of the most well-known and understood algorithm in statistics and machine learning. Here, linear regression is a linear model. Examples that assumes the same x variable input and one output variable y, that is y equal to mx plus c. Imagine we are predicting the distance travelled. It is denoted by y from speed x. Here our linear regression model representation from this problem will be y equal to m into x plus c, or distance equal to m into speed plus c. Here c is the coefficient, m equal to y-intercept. Here from the examples, time is constant, the speed is variable, the distance also variable. Here speed is 10 m per second, distance is equal to 36 kilometers. The next speed is 20 ml, the distance is 52 kilometers. Next the speed is 30, the distance is increased. Here time is constant, the speed is increased as well as the distance also increasing. Next we take the constant values distance. Here speed is 10, the same, we consider the same values. Speed 10 meter per seconds, the time is 100 seconds. Next one, the speed is increased 20, the time is 50 seconds. Next the speed is 30, what's the time? Here the time is reduced. The distance is constant, the speed is increased as well as the time also decreases. Time is constant means the speed increase as well as the distance also increase. Here distance is constant means speed increase but time is decrease. As the speed increase, distance also increase. Hence the variable have a positive relationship. The both variables are linearly increased when it is the positive relationship. The first graph is represents the positive relationship. Speed increase, distance also increase. Here m is positive slope of the lines. C is the y-intercept of line. So y equal to mx plus the model, the speed of the persons. The next diagram is the negative relationship between the time and the speed. As the speed increase, time decrease, hence the variable have a negative relationship. Here speed is increased, time is the decrease, is the negative. Here m is the negative slope of the line. Here y is the time taken to travel a fixed distance. Mx is the speed of the persons. In linear model, we are not interested in the intercept A. but only in the coefficient b. The coefficient b represents the relationship between x and y. Here b is the positive, x has a positive effect on y. That is, x is increase, also y increase. In case if b is negative, x has a negative effect on y. That is, x increase but y decrease. It's the negative model. Here, if b equal to 0, there is no effect of x on y. So, it's got three conditions based on the coefficient. Coefficient factor b is positive mean that's the positive relationship. B is negative, it's the negative relationship between x and y. In case coefficient is 0 means the no effect of x and y. It's the diagram representation based on the coefficient value. B greater than 0 means it's the positive linear relationship between x and y. The second one represents the negative linear relationship between x and y in condition b less than 0. Next one is the hypothesis testing in the regression. Here regression tests the null hypothesis. It is represent H0. There is no effect on x on y. That is coefficient b equal to 0. It is the null hypothesis. Next the alternative hypothesis H1. That is an effect on x on y. That is b is not 0. That b is not 0. If either b is positive or negative. If the null hypothesis is rejected, we reject the hypothesis that there is no relationship between x and y, and hence we can conclude that there is a significant relationship between x and y. This is the things is involved in the regression and the linear regressions. Thank you.